Hi guys, welcome to the next installment of Local DBA Tutor. Today I'm going to show you how to basically perform some tuning techniques, or some sort of to get your optimizer to work, for the best possible performance for your database. So basically, again, it's just to enhance your performance of your database. Okay, these are the things I'm going to cover. I'm going to first cover basically what is the Oracle Optimizer. I'm going to go into basically what's the role that it plays inside of the Oracle software. Then I'm going to focus on basically I'm going to introduce you to the cost-based and the rule-based role selection in Oracle Database Administration. Then I'm going to focus on basically just understanding execution plans in Oracle. I'm going to go into details as far as what is an execution plan. What's going to cover basically basically in terms of cost-based, there's a flexibility to cost-based. I'm going to go into pretty much just how much latitude you have in using cost-based a cost-based role selection. And then I'm going to cover the factors for effective as well as non-effective execution plans. Different things that you have to consider, that actually would make your execution plan ineffective or effective, either or. And then I'm going to focus on indexing, and basically just and also just clustering raw data. And then I'm going to focus on memory cache and Oracle Optimizer again, to sort of to get to sort of there's basically a special sort of like bond that ties these two, the memory cache and the Oracle Optimizer. I'm going to what that bond is, and how you can use that to again just get the best out of your Oracle software. So basically, okay, so what is the Oracle Optimizer? So the number one is basically the Oracle Optimizer is just, again, it's a key component of the Oracle software. You're definitely gonna encounter just just know that basically just give me 1 second, I'll be back. Okay, so as I was saying, give me 1 second. I made a mistake. There you go. So basically, as I was saying, basically you definitely get to get a sense of what the optimizer is the more you use the Oracle software. And then basically, two of the things that the optimizer does inside Oracle software is basically it performs execution plans, and it retrieves the raw data. So basically, anytime you issue a query, basically the Oracle Optimizer is that component, or that performs that function for you. And then it goes inside the database and retrieves the data on your behalf. So in terms of the Oracle Optimizer, you have two methods that you can use. You have the cost-based method to basically to do those two things, to perform the execution plan and retrieve the raw data. And you also have the rule-based method. Again, I'm going to go into details what these two are. In terms of the modes, basically how you enable the cost-based and rule-based is basically you would put in Optimizer mode, and then you would just type in first rows, and then the X stands for the value of number of rows. So if you wanted to just have quite the first row inside the table, the first 10 rows, the first 100 rows, or the first 1,000 rows, you can do all those things. You can perform all those separate queries, or you can just put first rows, and the optimizer is gonna be able to retrieve just the first few rows of your in the table, or you can also use the all rows, where basically it's just gonna, it's actually more for a this is just you know, you're giving the optimizer a chance to just you know, take its time and do the right retrieval. So basically, you actually issued it. You actually used the first row to be able to have like quick you know, retrievals for the data, and then this one is to allow for the optimizer to take its time in retrieving the rows. So basically, it's just, it depends on which environment you're in. And then again, this is just a cost based. This is how you enable the cost based method for for retrieving your queries, retrieving your raw data. And then you have choose. You can also just enable choose. And basically, what choose does is actually it's gonna switch back and forth between the rule based and the cost based. But actually this only applies to, I believe, Oracle 10G, because from Oracle 11G, what happened is that the choose value is actually made. I mean, the choose value is actually made obsolete. So the reason why is, so basically basically what happens is that if you put your because the rule base is actually, it's not being used, it's not sort of it's, you know, it's still available, but it's really being used. But because by default you have the cost based you know, sort of like, you know, configuration for the optimizer, what happens is that, you know, when you put choose, you know, it's just gonna revert to the cost based method, because that's what's enabled by default. And so as I just said, the choose is going to revert to the cost based, because that's what's configured on on the Oracle software by default. So I'm going to show you now just a you know, how to basically just get a sense of, you know, what the different values are for your optimizer mode parameter. So basically what I'm going to do is, so I'm going to log into my one of my databases, and what I do is I'm gonna see what optimizer mode is enabled. Is it cost based, or is it rule based? So I'm gonna issue this query, show parameter optimizer mode underscore mode. So as you guys can see, it's actually it's actually first row. So that means that the first few rows are going to be queried whenever you know I issue a statement. The first few rows are going to be retrieved. I mean, and it's going to be a I'm doing this to just get the optimizer to get me the data as fast as possible. And again, you know, you can also specify just how many, the exact number of rows that you want to be able to retrieve in that short period of time. So basically, once you figure out what your optimizer mode you can actually you know, use the different different commands how the system is set. Optimizer. So what I can do is, if let's say I want to you know, switch my optimizer mode to, let's say, first rows, let's say 100. Basically, you have two choices. You can actually just set optimizer mode. You can change the value to the system, or you can change it to your particular session. So what I'm gonna do is, just because, you know, this is a short demo, I'm gonna change it for my session. Set optimizer mode to first rows underscore 100. System has been altered. So if I issue that same query again, show parameter optimizer mode, it's gonna show first rows 100. So basically, that's the number of rows that are gonna be retrieved whenever I issue a statement for raw data. So and so, okay, back to what I was saying. So also you have you know, you also have rule based the method. And but basically with the rule base, it's actually deprecated and it's not as effective. So what happens is that basically you it's not so okay. The way that the way that the raw data is retrieved in Oracle is not is very, by the optimizer is very, it's not, it's basically it's just it's not based on raw data, it's based on statistics. So again, going back to the point that I was making earlier, the reason why the choose is going to revert to basically just using the first word or the cost based method is because this is actually based on the rule base is not based on statistics at all, and the optimizer solely relies on statistics to be able to retrieve the raw data on your behalf. So what I'm saying is that the rule base is deprecated because since it's not what it does is not based on what it does is it has nothing to do with statistic gathering. You would only the optimizer will only be able to use a cost-based method because the cost-based actually allows sort of provides the optimizer with the statistics that it needs to be able to do the to perform the queries for your SQL statements. So in short, optimizer basically relies on statistics to perform the reads that you're requesting. It doesn't know how many rows you have in your database, how how many blocks you have. It's not aware of any of those things. Only thing that it knows is that basically these are the statistics that have been gathered, and I'm gonna base my reads on these statistics, and I'm gonna be able to retrieve the data for the user. So basically, this is just a diagram of the cost-based optimizer as well as the rule-based optimizer. So if you look at so basically what you're a user, right? So every time you issue a query, it's being parsed, in memory, so that's fine. But when you get to this point, right, there are two choices. One is the cost-based optimizer, and what happens with cost-based optimizer is that basically an execution plan is actually queried for your is actually created for your for that query. So the optimizer is going to say, okay, so the user is asking me to get this raw data, but let me see, should I perform a scan? What type of scan should I perform? Should I perform a full table scan? Should I perform a range scan? And based on that, it's going to be able to basically just perform the reads of the rows inside the blocks to get that information for the user. So basically, this is just how what it does. So from the cost-based optimizer, you go into the query plan, and then you go into the row source is actually sort of a it's another name for row source is basically just table. So it's it sort of comes with an execution plan to for the table again. So basically after that it just goes to it actually executes the SQL for you, and then that's how you get your results. So number one is this is very important. You get your this is the reading. Let me go back. So this is where your table is being read. A table is also known as a row source. A table is read, and then you have an execution plan that's created, and after the execution plan is created, then you have the results. And basically, and in this part, what happens is that you have a lot of information. Again, this is going to be a keyword when you're dealing with optimizer statistics. Again, the optimizer performs is able to service the request based on the statistics that are gathered inside the Oracle, regarding the objects inside the database. So the more sticks you have, and the clearer they are, the easier you make it for the optimizer to do the work for you. So in terms of the value for the optimizer, by default in Oracle 11G and 12C, it's actually just all rows, and you gotta use the commands that I showed you earlier to switch this value at the first row, or and again, so you have basically Oracle by default just wants just it's sort of like nudging you to sort of look at the cost-based approach, which is basically the more efficient way of querying data, as opposed to the rule-based approach, or even you just using the choose, which is again, as I've already showed you earlier, is deprecated. So basically, again, the cost-based is actually preferred over the rule-based. And then also what you can do is you can use hints when you are, to tell the optimizer directly that, okay, so optimizer, I want you to look at this data. I want you to, as opposed to having, again, fundamentally what you need is statistics, right? But what you can do is you can let's say you have this value, or you have this configured on your system, and you want to bypass this, and you want to have the optimizer just go in and just find the first few rows, and this is the default mechanism for querying data, right? So what would happen is that if once you put a hint inside of your query, so inside your SQL statement, what's going to happen is that you can choose these different hints. The first row is X. As I've already showed you, this can be 1 to 1,000 multiple values. But you can also choose all rows. What's going to happen is that this is actually going to bypass this default setting, and it's going to perform basically exactly what you're asking, which is exactly what you're requesting in the hint. So these are actually referred to as cost-based hints. Again, you have there are multiple hints that are out there, and you can spend some time if you like to just research which ones you can use to get you to sort of like enhance the different aspect of the Oracle database. And so basically, as I've already told you, basically the optimizer is not performed. It's not programmed to be aware of database data, any raw data, any object data. That's not what the optimizer is performed to read. Basically, what it does is, again, it's just everything it does is based on statistics, and also with the optimizer, so you can have it, even though everything is done on statistics, you can actually bypass some some default configuration to get the optimizer to do exactly what you want it to do. Again, you can actually just send the specific directives to the optimizer. And also with the optimizer, it's very configurable. By that I mean you can there are a number of settings you can set. Number of configuration you can set for the optimizer, and it's actually gonna you can modify it to just to be as for optimal performance. So even going beyond optimal performance, because again the optimizer just gives you a lot of latitude in terms of how you want to how you want to query your data, and how effective you want just the different action inside the Oracle software to be. So again, this is a very fundamental question, right? So why the cost-based over the rule-based row selection? So basically, in terms of using a cost-based row selection, basically what happens is that you can use it in a couple of ways. So you can actually just set the configurations early on before using the software, or you can just set it while you're troubleshooting the software. So those are your two options. So basically, again, and then you can just imagine, different situations would call for different, actions, right? So if you have an initial configuration, you figure out that's not working, then you can definitely change to another configuration. That's something you can definitely do. So, but these are the two options that you have in terms of performing configurations for your for the optimizer to be able to apply the cost-based row selection method. So basically, and then what you should know. So Also, again, so I'm gonna this is gonna be very important. So you have to be able to know your data. So when I say know your data, you have to. So if a user comes to you and tells you, okay, I'm experiencing, a very slow, a very slow response time, and basically you just have to be able to, you have to just be able to, so like know know which objects for sure the optimizer might be performing some full table scans on, or also know which objects you have indexes on. So that's just something basic that you can figure out. Um, as you're just administering over different databases. So you have to figure out which query is giving you a hard time. Which query or which queries? It could be multiple queries. And basically, and also just how complex is that query exactly, right? Because queries you can have just a getting information from just one table. You can have joins. You can have different so you can have a number of different operations be performed on it with the data. You just have to know exactly what the structure is of that query. Maybe you might be able to do some rewriting to sort of make it less complex for the optimizer to to read it, or to make some to be able to get the statistics forward. So basically, and then this is another question you might ask yourself, so if I have a really complex query, should I just cache that data, cache the data for that particular query? So let's say you have a multiple joins, you have subqueries in your SQL statement, right? And you want to be able to just have that in memory. But the thing is, you can do that, but it's actually just think about it this way, right? So the more you have on memory, then what does that mean? The less space you're gonna have for the data from other operations to be stored, temporarily inside the database. So the purpose of having these different blocks inside of inside of the the OCO, the memory, the memory structures of inside of OCO software is to just have all these blocks are supposed to be temporary, temporary storage areas, right? But if you actually just cache them, meaning that you want to be able to constantly refer to them, again, because you figure, hey, this is a very popular query. Again, what you're doing is the more you cache into memory, the less blocks the less the lesser the number of blocks that you have available are, and that's gonna eventually just cause some difficulties. I'm gonna go into greater details on what are the best ways to do the caching for your inside of Oco software later on. So there are a number of tools you can use to be able to find out what the bottlenecks are, or basically the reason for the long wait events. You can use the Enterprise Manager. It's a graphical tool that once you install the Oco software, you can basically just configure the Enterprise Manager, and then on your system, and you can actually access it. It's gonna give you what you're doing with the command line. Using SQL Plus, you'll be able to do all those things just with a drag and drop, just clicking using your mouse. So basically, inside of the Enterprise Manager, you'll be able to access the different queries that are just being that are just taking up up all the resources, taking a large amount of time to complete. By just going to the performance tab, the performance tab, and it's going to show you which queries are responsible for the slow response time for your users. You can use the Enterprise Manager, or you can also use an awesome utility that you find that's part of Oco software. Basically, it's one of the offerings of the Oco software. That utility is actually called a StatsPack. Basically, what you do is you just, again, I've already covered this, but what you do is you just create a user, perf that user, and you're able to create snapshots for your for your system. So basically, let's say that user comes to you and tells you, "Oh, I'm experiencing terrible response time. Can you help me out?" What you can do is you can just ask the user, within 5 minutes time period, you're gonna basically just create a snapshot, a starting point. You're gonna have that user, just perform, just use, just quite, just be an active user for about 5 minutes, and then you can perform another snapshot, and then you be able to basically just assess what the root cause is. It's gonna show you basically which queries are taking too much time, and then that's another way to just like isolate the queries that are problematic in your system. And also what you can do is you can basically you can also use like performance views. I don't want to say, okay, performance views, but also data dictionary views. So there are some parameters that can actually just give you some sort of like a window look into like what a problem is. Again, these are just views. You can query them, and you'll be able to get a sense of what the root cause of of that performance degradation is. Again, when I say high weight events, it's just it's just referring to the performance of the local software. And then why you use cost-based over rule-based? Basically it's just again, you might have so what does optimizer do? Basically what it does is it's perform execution plans and encode the data for you, and then you may or may not give the optimizer directive. But basically again, how you deal with the optimizer is going to be based on on which objects you've identified as frequently being accessed, and also just how complex your query is. So again, it just goes into if you have a very complex query like select from, and then you have a word inside a word clause, you have a sub query that will be considered a very complex query, and that's basically the more complex the query is, the more work you're putting on the shoulders on. The more work, the greater the workload will be for the optimizer. So again, just be mindful of the objects that will frequently be used, and also just how complex your query is. So you definitely gotta know what architecture is for your database. And again, so just figure out what is popular inside your database per se, and then sort of like structure the local software in a way that the optimizer is able to just basically just do less work because of how common the operations are inside the system. So basically, in terms of just understanding what the execution plan is inside of Oracle, right? So typically what you have is, okay, so what you typically have is you have a select statement with a from and then a word clause, right? But basically, if that was the case, then then Oracle would be it would not be a very useful product, right? You gotta make some complex somehow. So by complex I mean I'm referring to like you gotta be able to add different objects. Let's say you have a department table, and then you have a manufacturing table. You want to be able to figure out, okay, which part, which that's actually a really bad example. I'm just gonna go with that example. So you have a department, you have a manufacturing table. So you want to figure out, okay, I have a department table. So who is part of the department table, and then basically and how does that user who is part of the department table, how does that user what are some of the things that ties him or her with that sort of links him or her to the manufacturing table, are they, are they part of, um, are they part of, do they have like, are they part of, is that the department that they work in? Actually, you know what, I take that, that's a really bad example. Okay, let me just, okay, let's say you have departments and you have employees. Okay, that's a better example. Okay, with the permanent employees, right? You have employees. You would just have, you would have an accountant. You would have a financial, advisor. You have all these things, right? And then also in the departments, you would have accounting. You would have, manufacturing. You have so many different types of departments. So basically, let's say you want to figure out which employees work in which department, right? That's the usefulness of having the Oracle software, the Oracle database, is that you can actually just perform a join operation to get those two pieces of information and tie them in. It's just to kind of like have a laid out reading of, okay, let's say John Smith works, he's an accountant and he works in a, obviously works in an accounting department, so you won't be able to figure it out. You're only able to figure it out because you're able to perform join operations. So again, that's just basically just again, just what I'm trying to do is to just make the case for just having a more complex Oracle software. So when I say join, you can have different types of join. You can have just regular join. You can have outer join. You can have natural join. You can have just indexing. You can have sequences. You can have database. Basically, there are so many aspects of Oracle software that are bound to make just to make it more and more difficult to use, but also again even though it's gonna get more difficult because you have to get it because the more difficult it is, and the harder it is to understand, the more secure it is. But then again, what you can also do is you can also just learn the various methods to to be able to overcome those back alley ways of administrating over the database. So this is just the complexity. I'm just referring here to the complexity of the Oracle database, and also so basically so when I say back alleys, right, what I'm actually referring to is the if you're able to implement all these different sort of like unique aspects of the Oracle software, right? You can basically just entwine all these into one point, right? What you're doing is you're gonna make it again. It's gonna be more difficult on the optimizer because as I've already told you, again, what the optimizer does is it's not the optimizer doesn't look at the raw data. If you have an object, going back to the example with the department and the employees tables, the optimizer does not know what's inside those tables. What it does is it bases the reading, creating execution plans and basically just the response to you to your request on the statistics. So if you have incredible statistics that are set up, then you have incredible response time for your queries. So again, it's going to, again, with Optimizer, the work is going to depend just on the database operation, if it's cache memory or not. Again, what a raw ID location is, database size, and all these different things, and also the distance of the read. Again, all these pieces of information are actually what amount to just having the statistics. That's available for Optimizer inside the Oracle software. So in terms of performing joins, you have what's called that's what's referred to as an inner join. Basically, what it does is it allows for a user to be able to so like point to specific data sort of. Okay, so basically, okay, I'm gonna go into the query number one. So what you have is you have, okay, so that column one, this should actually be just let's say you want to query table 1 and table 2, right? But the thing is, let's say this was X, but again, never mind. So okay, it's column 1, column 2. So what you do is you would just put from table 1 inner join table 2 on table 1 period, column 1 equals table 2 column 2. So the reason why this is gonna be a perfect inner join is basically the inner join is to retrieve matching raw data. So basically, you be retrieving just the rows that are in common with these two columns. That's what an inner query does. It just retrieve column data that are common in both tables. This query, the on clause, this might need to be configured. Let me see if this is right. Table 1. I think what I should have done is I should have this should have been a star here. Like, it's better to just have a select star because you're never sure what columns you're going to be retrieving. So basically, recommended way to do this is to just have a star, and then you put the two tables, and then it's in the on clause that you're actually going to be specific. You're going to say, okay, I'm going to have information from table 1, account for table 1, and then this is I'm gonna see if it matches with information in column 2 of table 2. So that's just the recommended way of doing it. And then you can also use, again, this is known as a comparison sign. You can use an equal, you can use a greater than, a less than, greater than and equal to, and less than and equal to, and then you can and again, so the on clause is actually what it does is it basically is just sort of it's the agitator for the for this comparison for the two columns. Basically what it does it drives, it's basically you would let's say the on clause is there to just sort of give you that open window to just make your query more and more configurable, right? So with on clause you can do all these things, but you can't do it with a using clause, because with a using clause you be just querying one column, and again what you're doing is you're joining two tables. So that's the use of it on clause. Is basically just gives you a lot of flexibility to just make the join operation as unique as possible. So again, this is another example. So here I have it done the right way. So what I did here is, this is another inner join, and here what I did is actually I use a select star from table 1 join table 2, and then what I did is I have a using clause here. Again, a using clause is to get you use the using clause is to get the matching column row data. So again, that's why I just have here same columns same column data inside the two tables, and that's what these are the two queries that you can use to get the matching data. You can also use natural joins, and again the overall name for these joins are equijoins. So anytime you hear equijoin, just know that you're going for the matching row data for the columns. And when you hear if you have equijoin, then the opposite of that would be a non-equijoin, where it's not matching. So just keep those two terms in mind. So here at the bottom, you also have conditional queries. So here you basically just have a here you just have, like, okay, for example, you have a select star from table 1, table 2, or table 1. So you have an and clause here. You have multiple and clause, right? And you also have a not equal to. So basically, when I say conditional query, what I'm referring to is you have all these. You have a number of different conditions that have to be met for the row data to be retrieved. So if this condition table 1 equals the value and this condition do not match, then you're not gonna get your raw data value, right? Your raw data. So they all have to match. So that's why I call it a conditional query, because you have again, this is a very complex query. It's not, it might not always be this way, but basically this is just to give you a sense of just what exactly conditional query is, and how the more conditions you add to your query, again, the more will have to be satisfied for you to be able to get your raw data. So again, so here I'm just ending my query. I have it's not null here, and then I have a it's not null. So basically what I'm saying is that I definitely want to get a raw data. I'm not sure if how you're able to do it, but this is just to ensure that definitely it's not null is gonna be it's not gonna be configured as a one of my as part of my result set. So, and also in terms of the cost-based method, basically it's going to be based on cardinality, right? So what cardinality stands for is just the number of rows. So basically you again, so going back to what I covered earlier with having the first rows with the value. This is really important for the optimizer, because you can use it as a directive for the optimizer. But also just overall, if you have just plenty, right? If you have less rows, that's going to be a smaller workload for the optimizer. If you have more rows, then that's going to be a bigger workload for the optimizer. So that's very simple, right? It's just based on cardinality. How much workload are you putting on the back of the optimizer? And again, just to get get I don't know why I have this here actually. Equal is exact value. Yeah, just again, so yeah, so I already covered the greater than and equal to. So that's just how you can configure your SQL statement by just placing these different comparison signs inside of your query to get different raw data. So as I was telling you earlier, the optimizer really struggles with this database content, right? So let's say, if you have an expression, if you have a bound variable, and if you have clustered data, if you have columns that are correlated values, and if you have a predicates, these are just some of the reasons why the optimizer would really struggle with your query. Again, expression is just sort of between and I just went over that. So again, it's just what you're doing is you just again it ties in with the different conditions that you're setting in your query. Bound variables are sort of the same thing. Values clustered again. So do you have a do you have a table where similar kinds of data are stored, or are they all over the place, and you have optimizer just do the different sort of like get the different piece of information. Do you have columns that contain the same values? Again, that can be confusing. Again, so what I'm trying to say basically is that the optimizer is going to be very busy if you with the amount of workload that you're putting on it. So actually now I'm going to just demo. I'm going to demo just a very sort of a join operation. So let me do this. I'm going to be using the HR schema and I'm going to use the countries and the regions tables. So I'm connected to this, right? So what I'm going to do is I've already created a okay, so I'm logging this corner. So I've already created the plan table. Again, use the plan table to store your execution plans. So what I'm gonna do is I'm gonna issue a select. First of all, I'm gonna see if I have any information inside of my plan table. Right? Select from plan underscore table. Okay, so that means that I have no execution plan stored inside of my plan table, right? But typically, if you don't have a plan table created yet, you would just run this query. You would just run this SQL script actually, the utlx plan that SQL script, and it's going to create the plan for you. And again, so you just store your execution plans. So what I'm gonna do now is before I go any further, so let me make sure I enable some of these configurations for local software. So author session set statistics underscore level. So what I'm just doing here is I'm going to basically just make the Oracle software just tell me exactly what's going on. Like everything that's taking place. I want to know what it is. So let me do this. Level 2. Oh. Okay. So I've already set the statistics level to all, and then what I'm gonna do now is I'm gonna issue a set echo on timing on line on. Timing on. Jesus, guys. Set echo on. Timing on. Line. Yeah, let me just do this. Okay, set echo on, set timing on. That should be line, but let me try it again. Set line. Okay, so again, never mind. I'm just gonna not worry about that for now. So now what I'm gonna do is I'm gonna connect to the HR schema. No, connect HR. Okay, so I'm logging as HR. So select. And again, so what I'm gonna do now is I'm just gonna confirm that I have all these different tables inside the HR schema. User underscore tables. Again, so it's just gonna tell me how much time it took. That's the reason why I set up this the timing and and also the echo to just again I want to be able to just look at all these these different values for these operations. So so again, as I've told you already, I'm going to be working with the countries and the regions table. So let me do this. I need to figure out the structure of the countries table. So describe countries. So basically, countries I have country ID, country name, region ID. So let me do another describe. And also, by the way, the DESC stands for describe. You can do describe, or you can just use the acronym. But again, let me just show you guys. There you go. So basically, this is the structure for these two objects for the countries and the regions table. So what I'm going to do now is I'm going to create an index. So again, so when you see, you can tell that these are the primary keys, right, for these two tables. Country ID is the primary key for the countries table, and then the region ID is the primary key for the regions table. What I'm going to do is I'm going to create a primary key for the country name. Yeah, primary key for the country name. So let me see. Create. I might already have an index created, as I was doing beforehand, but let me make sure. IDX on countries, country underscore name. Okay, never mind. So I just create an index. So basically, what I'm doing now is I just created an index to sort of you know, again, so I even though I already have a primary key here, like I just create an index to, let's say the optimizer is going to be looking for, you know, hey, I'm gonna be, if this guy wants to do a join for these two objects, right? And you know, if I look at this object and I can't find an index inside this object, you know, I might you know, for the optimizer, it might mean that you know, it would have to perform a full table scan, which is something that you want to avoid. So I just create an index in there to just sort of, you know, give the optimizer a hunch as to basically just how to better find the data inside the table. So let me do this. I have, okay, we're going to bring this back. There you go. So basically what I'm gonna do now is I'm actually going to I'm gonna perform a join. I'm gonna do it very like I'm gonna do a join statement, but I'm gonna perform a join operation, but it's gonna be some you know, actually, you know what, not a join, but I will call this, it's a subquery. I'm gonna issue a subquery I'm gonna perform a subquery operation. Select star from regions, select region underscore ID, region underscore name, count as num regions, from regions group by region underscore ID, region underscore name, ordered by num region. Let me show these right. Num region, okay. Ascending region underscore ID, region underscore name, close it, where low num less than or equal to 10. Again, just for, you know, for clarification purposes, right? So this part is where you would have a predicate. So anytime you hear the word predicate, right, it just means that anything that's after the word clause, just for you know, for future knowledge sake. So I have this, it's not properly ended. And what did I do? Select star from regions, select region ID, region name, count as num. No, there you go. So this is where I went wrong. So I have num regions, and then I have number regions. So I'm gonna get rid of these two. Let's try it. Let's see what else I went wrong. Okay. Select region ID, region name, count as num regions. Okay. Num regions. From regions. Group by region ID, comma, region name, order by num regions, ascending, comma, region ID, region ID, region name, whatever num is less than or equal to 10. Not properly ended. Get out of here. Okay, let me do this. I should have this query stored in my somewhere in here. Come on. There you go. So I should have it. There you go. So this is a query. So what I'm gonna do is I'm just gonna execute this SQL script. So it's C app test equals. So let me do this. C add C app test that SQL. Again, I need to put the SQL script at the end. So yeah, so basically I just executed query, right? So let me see. Let me just make sure. So yeah, so this is a mistake, right? So when you're issuing a I made this mistake the first time, and I gotta I made a change in my slide, but obviously not. So basically, when you issue a select from and you have an inline query, it's also known it's a type of a subquery. Basically, you just have to put select star, but you don't put the actual table, because this is gonna be the what the table information is gonna be coming from. So this is just a subquery operation that I just performed. So we have this query, right? And I'm connected as the HR user. So what I'm gonna do now is I'm gonna do this select star from table open paren dbms underscore explain that display close paren. Can I fetch that explain? Okay. Again, it says cannot fetch the last explain because obviously I don't have any information in there, right? So, and also I can do this. So I have two choices. I can do a regular explain that display. I can just do an explain a display underscore cursor, right? You get more information with a cursor. Actually, yeah, using this procedure, the display underscore cursor. There you go. Okay. So what I'm gonna do is, okay, so I already know which query to use to be able to read my execution plan. So what I'm gonna do now is I'm gonna do this. I'm gonna issue this statement: explain plan for. Actually, this is what I should have done. And use explain plan for. What I'm gonna do is I'm gonna open up my test script, copy it, close this, go to my window, paste it, and voila. So basically, what I did is I just stored the execution plan rows, the basically the breakdown of execution plan inside of my plan table. So the query that I issued earlier to see how many rows are in the plan table. So if I'm issuing like the same query now, select star plan underscore table. 6 rows selected. This is definitely more than I was asking for. Anyways, select star from plan. Okay, so basically I just have more. Like I'm getting a lot more. I'm getting just more information than what I was looking for. So what I'm gonna do now is, no, not this. But let me disconnect from this before I get ahead of myself here. Right? Okay. Let me select. That's not what I meant to do. I should have done count. The select star is just going to give me all the information that that's inside the plan table. So I should select the count to get a number of rows from plan underscore table. Okay, it's been flushed out obviously, so let me do this. Explain plan for okay. Let me do this. Okay, I'm gonna pause right now and I'm gonna pick it back up in a little while. Thanks a lot for watching.